The next type of compounds to focus on are acids. Acids are all compounds that start with a hydrogen ion or H plus ion. The two types we focus on are binary acids, which involve one other atom bonded to hydrogen, and oxyacids, which involve an oxyanion, a polyatomic ion, combined with hydrogen. The binary acids are the most simple, both in identifying and naming, because we always have hydrogen and a negative ion with it. To name them, we use the prefix hydro, the name of whatever is bonded to it, and we change the ending of that to IC. And then we add the word acid to the end. Now the prefix hydro is not because the acid contains hydrogen, but because it's dissolved in water, making it an acid. Here are some examples of binary acids. HF, we use fluorine with the ending changed to ic, and we add hydro to it, so it becomes hydrofluoric acid. Next one, you have chlorine, so it becomes hydrochloric acid. In the next one, bromine makes us hydrobromic acid. And in the next one, HI is based on iodine, so it becomes hydroiodic acid. One more example to note is H2S. The reason for two hydrogens, because it looks a little different than the others, is because sulfur has a 2- charge, so it would take two hydrogens to balance out the charge of the sulfur. Now this would be hydro, and sulfur, we don't take off the UR and change the ending, we just add the ending on, and it becomes hydrosulfuric acid. Oxyacids are named based only on the second ion also, but this time there's no prefix, it's just the name of the ion with the ending changed. Our polyatomic ions all end in ite or ate. When we make them into acids, we change the ending to OUS if it ends in ite. If it ends in ate, we change the ending to IC. So some examples. Here I have nitrite. So the name of the acid is nitrous acid. In this one I have nitrate. So this becomes nitric acid. There are two exceptions, one's with sulfur and one's with phosphorus. We don't strictly use sulfate, sulfite, phosphate, phosphite. We actually take the name back to the original element and then change the ending or add on the ending. So this one ends in sulfite. It doesn't become sulfus acid, it becomes sulfurous acid. And sulfate becomes sulfuric acid. Now the important thing to remember when you're naming acids is if you see hydrogen at the front of the compound, it's going to be an acid. Whenever you see hydrogen at the beginning of the compound, it's going to be an acid. Now, that's all the examples we have up here, but I'd like to do one or two more just to make sure we have it down. So let's take a look at this example, carbonic acid. You don't see anything about hydrogen in the name except the word acid. When you see the word acid, that tells us it has the H1+ ion. Now this one is based on carbon, and IC comes from 8, so it started as carbonate. The formula for carbonate is CO3 2-. So we next look to see if our charges cancel. I have a 1+ here and a 2- here. They don't cancel, so I cross the charges. And I get the formula H2CO3 for carbonic acid. Try one more, perchloric acid. The word acid tells me that I have the 1+ ion. Perchloric Perchloric would come from the ion perchlorate. Perchlorate is ClO4 with a 1 minus charge. Do the charges cancel? The answer is yes. Since they cancel, I have one of each ion, so perchloric acid would be H